Hello everyone, welcome to our channel. Today we will learn if a given number is a power of 2 or not. It is a very standard question and asked in many other questions also. So we have different method to solve this. Uh, the first is using loops, which is a normal method which everyone uses. But the other two methods are smart. So I will tell you all the three methods. The second method is using log function. The third method is using bitwise operation. So let's study one by one. So the first method is using loops. So let's understand you are given an integer n. So it is power of 2 or not. We have to check it is power of 2 or not. So let's take n is equal to 32. So firstly what we think, we firstly check it is even or odd. If it's odd, then it can't be power of 2. But if even, we have the possibility that that number can be power of 2. So firstly what we do, we check it is even or odd. For checking that, we can use a simple bitwise operation. If n and 1 is equal to 1, means it is odd, otherwise even. So here n, 32 and 1 is 0, which means it is even number. So firstly we will check that it is even or odd. So we found that it is even number. So what we do next, we take 32, it is even. So what we will do, we will divide it by 2 and then check the resultant number is even or not, because if a number is power of 2, means it is in the form of 2 to the power p. So at the end it should have only multiples of 2 only. So we will check one by one that at the end only multiple left should be 1. So the resultant is 16. Is 16 even or odd? 16 is even. So we will check 16 by 2. 16 by 2 is also even. So we will check 8. 8 is also even. So we will check 4. Then we will see 4 is also even. Then we will divide 4 by 2 and check. We found 2. 2 is also even, which is the least. If it is 2, we will stop, or we can stop after 1 also. If we get 1, we divide 2 by 2. As 2 is even, we will continue our process. So we will divide 2 by 2 itself. So the resultant will be 1. So 1 is the end. So we got that 32 is a power of 2, because using this whole process, we found there is no other multiple of 32 than 2. So 32 is power of 2. Let's take another number. Let's take 72. Let's take n is equal to 72. 72 is even. Even. So we will go to next step, 72 by 2, which is 36. 36 is also even. 36 even. So we will go to next step. The next step will be 36 by 2, which is 18. 18 is also even. So we will go to next step again. So next step will be 18 by 2, which is 9. Here 9 is odd. So we will stop this process. And we will stop this here. And we will conclude that n is not power of 2, because we found an odd number which is not 1. Means it is not power of 2. So let's take another example to understand it more clearly. So suppose in the beginning itself it is n is equal to 31. So it is odd number. So we will stop here, stop here. Not power of 2. So this is the first method in which we can use loop conditions and check whether the number is power of 2 or not. Let's move to our coding screen. So firstly we declared a variable n, which we take input from the user. Then we declared a variable which is power of 2. We firstly initialized it as true. So let's move to our first method. What first method was? It was using loops. So firstly we will check if n is 1 or not. If n is 1, then we don't need to do anything further. If n is equal to 1, it is power of 2, because any number we take it to the power of 0, it will result in 1. So 2 to the power 0 is 1, 3 to the power 0 is 1. So it will be true. We don't need to do anything further. Then we will check if n is not equal to 1, then we will follow a normal method. So we will use a while loop until n greater than 1. So what we were doing, we were checking that if n is even. If n is even, then we are dividing it by 2. If n is odd, we are breaking that step. So that is we are doing here. We check that if n is even. If n is even, we are dividing n by 2. If n is odd, we are just breaking the loop and making the variable is power of 2 false. So let's see, is this code working or not. So we entered 32, which shows is power of 2. Let's enter 63. It is not power of 2. So this code is working fine. So the method, you understood the method. Let's see another method. The second method was using log function, which was, so let's understand the method 2. What method 2 says is that using loops, using log function. Log function. We know a basic property of log, that if log this, so the m will come forward. So it will become m log a base b. This we know. So suppose if a number n is power of 2, means it should be of 2 to the power p form. So if we take log, then what should happen? It will become like this. So p will come forward. Suppose it's not power of 2, then what will happen? suppose we take n is equal to 32. N is equal to 32. So we take log base 2 n. So it becomes log 32 base 2. It becomes log 2 to the power 5. So 5 comes out. So we found that it is an integer. Means n is power of 2. Suppose it is not an integer. Then what will happen? Suppose log we take log 3 base 2. So what will happen? Nothing will. It is not a power of 2. So it will result some non-integer. Non-integer. So from here we can see that if a number is power of 2, so it will the log base 2 of that number will result in a integer, otherwise non-integer. So what will it result? It will result something 1 point something, 1 point something. It will result 1 point something. So it is not an integer. So how can we check? Suppose if we take the floor of log 2 base n and seal of log 2 base n. So this should be same number. Means if this part is an integer, so what will happen? If it is an integer, then we take floor or seal, doesn't matter. So it will be same. So the logic will be if floor of log n base 2 is equal to seal of log n base 2, then it is power of 2. Otherwise not. So this is our second method, which is just one line method. So this is very useful method, and we can do calculation very fast, and it is very short code method. So the second method was using log function. So if floor log n base 2 is equal to seal log n base 2, then it shows that it is an integer. This part is an integer. This part is an integer if floor and seal of both are same. So if floor and seal are same, means it is an integer and is of the form 2 to the power p. So here we can say is power of 2 true. If it is not there, it means it is not power of 2. So this is the second method. So let's see it's working or not. We entered 31, so it's showing it's not power of 2. We entered 128, it's showing it's power of 2. So this method is also working fine. So let's see the method 3. The method 3 is using bitwise operations. We know a simple rule in coding that normal operations are always slower than bitwise. Why is this so? As bitwise deals with binary digits, so bitwise is always faster. So bitwise is always faster. In this method, we use bitwise, so the solution will be faster. The first point and the second point, it will be a one-line solution. In loops method, you have to use long code in which you have to perform while loop or for loop. But in this method, you have to just use one line of code. So let's see this method. So for this method, you should have some basic knowledge of bits. So if we represent any number, so how can we represent any number in bitwise form? Suppose we are given n is equal to, this continue up to 2 to the power 31. Let's given n is equal to 32. So how can we represent it in bits? So it will be 0, 0, 0, 0, 0 and 1. So we see a pattern that if a number is power of 2, then it's all bits before it and after it will be 0. But the nth bit will be 1. So what we can take, suppose if we take n is equal to 31. So what is n is equal to 31? It will be 1, 1, 1, 1, 1 and 0, 0, 0, 0. While 32 is 0, 0, 0, 0, 0, 0, 1. So this is n is equal to 32 and this is n is equal to 31. We see that if we take bitwise end of this, so it will be 0. So if we take bitwise end of this, so we see that it will become 0. See, 0 and 1, 0. 1 and 0, 0. So it will result in 0. If n is power of 2. So we can check if n and n minus 1 is equal to 0. So n and bitwise end n minus 1 is equal to 0. So it is power of 2. Otherwise, it is not power of 2. In next method, what we were checking? We were checking that if n and bitwise end of n minus 1 is 0, it is power of 2. Otherwise not. So we can see here that 32, which is n, and 32 minus 1, which is 31. If we take bitwise end of them, it will result in 0. Otherwise not. So here's the code. So let's run the code. 32 is power of 2. Let's take 256. It is also power of 2. So this third method is also working fine. Thank you.